Here's a solution to Rockswold number 7.4.81. So the problem is to simplify this rational expression, 1 over x minus 11 minus 1 over x plus 11 plus 1 over x. So this has three terms. It's going to work basically the same as if we only had two rational expressions to add, but everything will be just a little more complicated because there are three. So first thing to note is we are adding rational expressions that do not have the same denominator. So before we can add these, we need to arrange for everything to have a common denominator. So let's find the least common denominator that we'll use. So for our first term, the denominator is x minus 11. So we need a factor of x minus 11 in our least common denominator. For the second term, the denominator is x plus 11. We don't already have an x plus 11 in our LCDs, so we'll need a factor of x plus 11. And then in the last term, the denominator is x. We don't already have a factor of x in our least common denominator, so we will need one. So our least common denominator will be x minus 11 times x plus 11 times x. All right, so now we need to make this least common denominator appear. And to do that, for each term, we will multiply it by a fraction that has the missing parts of our least common denominator. For this first term, the missing parts of our least common denominator are x plus 11 and x. And since we're putting that in the numerator, we need the same thing in the denominator so that we have something over itself, which multiplying by something over itself won't change the rational expression we started with, minus 1 over x plus 11 times, and then we need to get the missing pieces for this one. The missing pieces for our least common denominator in this term are x minus 11 and x, and then same thing in the denominator, plus 1 over x times, and then our final missing pieces, x minus 11 times x plus 11. Running out of room a little bit. Over x minus 11 times x plus 11. Okay. Now we need to multiply these fractions together in each term. In the denominators, we don't really need to multiply them out. We need to combine these denominators, but we don't actually need to do the polynomial multiplication that results. So in this first denominator, we get x minus 11 times x plus 11 times x. And then in the numerator, we get x plus 11 times x times 1, but I won't write the times 1, minus, in the second term, the denominator is the x plus 11 we started with, times x minus 11 times x, and in the numerator, 1 times x minus 11 times x, plus, and then in the final term, the x we started with times x minus 11 times x plus 11. And in the numerator, 1 times x minus 11 times x plus 11. Okay. Now we've made quite a mess, but we now have common denominators in each of our fractions. So now we can proceed to actually adding these fractions together. And for rational expressions, once you have a common denominator, you add them the same way you add fractions. The new denominator, or the denominator of the resulting fraction, is the same as the denominators of all the individual ones. So x minus 11 times x plus 11 times x, and then the numerator is the sum of the numerators in your original fractions. So x plus 11 times x minus x minus 11 times x plus x minus 11 times x plus 11. Okay, now this the denominator is as simple as it's going to get. If we multiplied it all out, it wouldn't really do us any good. But the numerator is not simplified. If we multiplied everything out, we could combine like terms, and that would make the numerator simpler. So we should go ahead and multiply the numerator out. So we get, in this first one, distribute this x. We get x squared plus 11x minus, and then in this second one, distribute that x. We get x squared minus 11x plus, and then in this last one, we have to multiply this all out. You get x squared plus 11x minus 11x minus 11 times 11, that's 121. All over the same denominator, x minus 11 times x plus 11 times x. All right, now that we have everything multiplied out, we can go ahead and combine like terms in our numerator. Our denominator is going to stay the same, so let's just write that down now. X minus 11 times x plus 11 times x. Okay, so let's look at all of our terms with x squareds. So there's one there. Actually, before we do that, let's distribute this minus sign right here. So x squared plus 11x minus x squared plus 11x plus x squared. While we're at it, we can cancel this 11x and minus 11x right there. So minus 121. Okay, now we can continue to combine like terms. Our denominator, as ever, is x minus 11 times x plus 11 times x. Now let's look for those x squared terms. Well, here's a plus x squared. There's a minus x squared. Those cancel. And then there's only one x squared term left, this one right here. So we have an x squared. Looking at our x terms, we have an 11x here and an 11x right there. So that's plus 22x. And then minus 121. All right. Now, we've simplified the numerator. We should check if the numerator cancels. Or, I'm sorry, if the numerator factors. Because if the numerator factors, we might be able to cancel one of those factors with something in the denominator. So let's go ahead and check. The factors of 121 are, let's see, so we need factors of negative 121 that add up to positive 22. And the factors of negative 21, let's see, we want the bigger factor to be positive since we end up with a positive sum here. So our possibilities are negative 1 and 121, but those don't add up to 22. And negative 11 and plus 11, but those add up to 0, not 22. And then all the other ways of factoring negative 121 give us negative sums instead of positive sums. So that means that this numerator here doesn't factor, at least not with integers. It's prime. And since it's prime, we will consider it simplified. So our numerator is simplified, our denominator is simplified, nothing cancels, and so we're done simplifying our rational expression.